cloud system layer are defined as three different layers. The first is the top layer. There are Cloud Controller, CLC, and Water Storage Controller will be defined in the top layer. The top layer is used to provide the interaction or graphical user interface (GUI) to the client users or customer. The client user can give the on-demand resource requirement to the top layer, or just pick up or choose the computing resource presented in the top layer. So any interaction between the cloud operating system and the remote client user will be managed and presented in the top layer, similar to the presentation or desktop of the traditional operating system. The second is the middle layer. Since a cloud system will need a lot of physical machines to provide a huge computing resource, similar to the traditional environment. The data center will cluster some or many physical machines as one cluster, and there will be the cluster controller (CC) to manage the cluster computing resource from the physical machines. All the computing resource from different physical machines will be integrated as the one computing resource pool, no matter CPU, memory, storage space. All the computing resource will be merged as the computing resource pool and provide the pool information to the cloud controller. In addition to the computing resource, the data file system should be considered, since the big data is popular in the cloud environment, corresponding to the real physical storage space. One big data or huge data will be divided into blocks. Each block will about 64 megabytes, and merge or integrate these blocks. An original whole data can be presented. So in the middle layer, we also need a file system, elastic block storage (EBS). Try to divide the original big data and distributed storage in different physical storage space. Of course, in the future, we will introduce the data file system in the cloud system. And finally, there is the end layer. The end layer is called node controller. A physical computer is called a physical node. This node will has the responsibility to deal with the computing job the computing resource. So each physical node will increase a node controller to manage the real or physical computing resource and execute the computing job from the top layer and middle. Just similar to the traditional operation system. An operation system will deal with the physical hardware for the computing resource. So in the cloud system there are 3 layers, similar to the traditional operating system. However, in each layer, or each controller, there will be its own cloud operating system, which has different responsibility to deal with the information or the message between different physical controllers based on the network. So the cloud system is similar to the traditional PC. However, in different layers, they will have different role and different function to deal with the management. Here is the architecture of the cloud system there. From the top, there is the cloud controller (CLC), provide the graphical user interface to interact with the remote client user based on the network. The whole interaction between the cloud platform and the remote customer will be presented in the cloud controller. In addition, the whole possible available computing resource in the computing resource pool can be implemented in the cloud controller. Then there are several cluster controllers which manage the information in each cluster. And the cluster controller will increase node controller interface to interact with the node, physical node or physical computer. Then there are many physical computers or nodes which equates the node controller to manage its own computing resource and execute the computing job given or assigned from the cluster controller. So, a virtual machine rented by the remote controller may be the integration of the computing resource from the resource pool, and this resource pool is merged or will be an integration from many physical computing node or physical machines. Your CPU may be from one physical computer, but memory may be from another. Hence, a remote computer user, especially virtual machine user, doesn't need to know where the computing resource is. The customer only needs to rent the computing resource he on-demand needed. So the cloud system is a very huge integration of physical node. Hence, the characteristic of the cloud. First, on-demand resource requirement and service. And client user connect to the cloud operation system or cloud platform via internet or a network. And only when user needs the computing resource or the service, the connection or resource occupation will be needed. In other words, if the remote client user is disconnected, all the rented computing resource will put into the resource pool for other people or for the reused in the future. Hence, each client user can only rent the computing resource when he needs. In addition, the computing resource requirement from the client user can be different. No matter the CPU, the memory size, the storage space, each client user can give the on-demand requirement. And after renting, the virtual machine or the computing resource can be integrated and provide a service to the client user. The computing resource can be rapidly used. The second, the storage space is extendable. Based on the data file system for the big data, all the data will be divided into blocks. These blocks will be distributed storage. In other words, there's no single big data storage in the storage space on cloud. So the storage, especially blocks of the data, will be distributed, stored, and will be easy backup. You don't need to worry about the loss of the data. The third, distributed system and parallel processing for big data. Since a big data is already divided into blocks, and the storage space is extendable, it means no matter how huge the data is, we can divide it into blocks for processing. Considering the physical machine, we can try to distribute the blocks to different physical machines. It means the computing job is divided into several partitions for many physical machines. In the past, the distributed system already proved that the performance can be improved with the parallel processing. Today, based on cloud, we can use the Hadoop or the MapReduce. We can use the job tracker, task tracker to divide the original job to distribute the job into several partitions for further parallel processing. Since the resource on cloud is extendable, it means we can run a huge computing resource with the extendable storage space. With the stronger computing ability, the client user may obtain the computing result with higher performance or within shorter time. However, to use the Hadoop or MapReduce on cloud is not promised to obtain better performance. There are some reasons. Also, we will introduce the reasons why we cannot always obtain better performance on cloud. That will be introduced in our future class. Several business models for our clients. Most popular is the virtual machine service or business service for our client user. A remote client user can run the virtual machine with the computing resource it needs. A client user only need to give the requirement or choose the computing resource it needs. Then the cloud operating system or cloud platform can provide the on-demand required virtual machine for our client user based on network. There will be an IaaS service, infrastructure as a service. Also, PaaS, PaaS, platform as a service, can provide the virtual operation system or platform for our client user. Furthermore, the SaaS, software as a service, can provide the online application of software for our client user. All the service only need to be connected by the internet or network. So since we can provide virtual machines, we can provide the virtual operating system and online application. We can provide more flexible service for our client user. For example, we can provide a service no matter database or a web service. We all need the servers online. So a company can run a virtual machine, and based on the operating system applications they need, then a company can create a server on cloud without buying the physical machine. Today, the most popular business model is big data. Many international companies have huge data to be analyzed with data mining. To do the data mining, we need a huge computing resource, big data server. By using the cloud platform, we have more chance to deal with the big data with higher performance and obtain the computing result within a short time. Of course, if you are a data center company, you can obtain money from this service. Here are some cloud platform service examples. The service provided by the Google company. You can online access your personal schedule. In addition, the similar application such as Microsoft Office software, you can add your own data file, Excel file, Word file, served by the Google company, and online edit, shared, and storage. You don't need to buy the Office application software. Even the service provided by the Google company, you only need to access online without the payment. In other words, these services are the software as a service, SaaS, based on cloud platform. With the network existence, the client user can access edit the data file anytime, anywhere, by any devices. Hence, the software application employment will be different from the traditional. In addition to the application or software as a service, the storage can be also provided by the data center as a service to the client user or remote customer. The popular or famous company is Google. Google provides Google Drive, online storage space for the client user. In the past, you have a free space at least 5 GB. Now, it is increased. And the storage space can be accessed by different desktop operation systems, no matter Microsoft, Mac, Android, Linux. You can access the storage space via your laptop, notebook, PC, or mobile phone. In addition to Google, the Dropbox or other international company also provide the free storage space for the company or for the individual. You can access your storage space or data file just based on the network. Even you can backup your data file online or based on the cloud platform. Today, many companies already provide the service. The client user only need to create an international or an internet account. Then you can obtain the free space. You can upload your data file. Of course, this data file will follow the data file system on the platform. No matter how huge the database or data file is, all the data will be divided into blocks and stored in different physical machines or physical hard disks. However, the client user or remote customer doesn't need to know the real configuration of the storage space. In fact, the client user or remote customer only need to obtain, to add, to change the data file via internet without understanding or knowing the infrastructure provided by this company. In addition to the storage space, the cloud platform also provides the desktop user interface for the client user. A client user or a remote customer can connect to the desktop user interface by the web browser, just similar to the remote desktop control or a remote PC connection. Then on the user interface or the web browser presentation, you can find all the icons, all the procedure you use, just similar to the physical computer you used. Hence, even you use the Linux or Mac operating system, you can use the web browser connecting to the cloud platform Then you can obtain a Microsoft Windows environment online. You can still use the software on different operation system. Even if you are a program developer, you can create the development environment by your own self, just similar to the past platform as a service provided by the data center company. You don't need to buy the license or the software or the operation system. You just need to run and connect to the desktop environment by the internet. Now, what is the operation system, especially in the cloud platform? The cloud operating system is a set of a program. First, this operating system should manage the computer hardware resource, collect all the computing resource as one computing resource pool, and also provide a common service for application software. In the cloud environment, the cloud operating system should manage the system resource. For example, process management, memory management, input-output I/O device management, and data management. The cloud operating system is still similar to the traditional operating system. To collect the computing resource or manage the computing resource is still similar to the traditional operating system. In addition, the cloud operating system should provide the computing resource to the application or software. The operating system should interact with the application and execute the command from the application or software. It just does like the same as the traditional operation system. However, there are still some differences. We will introduce later. Now, we introduce the basic components of the operation system. Similar to the traditional operating system, the operating system should include several basic components. The first is the kernel, which has the main responsibility to deal with the computing job. The second is the device driver. Any input, output, even hardware drivers should be embedded in the operation system. Then, the kernel can use the hardware resource from these devices. The third is the file system. The file system manages all the data file from the user. The file storage in the specific hard disk space should be managed by the file system. Without a file system, user cannot deal with the file or data storage in the storage space. The next is the application supporting library. Use the library, the software can be supported by the operation system. The last one is the command processor, or we call shell. These are all base components of the operation system, the same as the traditional operation system before. Here is the Linux operation system framework architecture. The physical hardware provides the computing resource or hardware resource for the operation system. A Linux kernel provides the kernel service to deal with the computing job. In addition, the file systems manage the storage space, deal with the requirement from the client user to access the data file in the storage space. The third component is the network protocol stacks. Currently, most operating systems can deal with the packet from the internet or network. So all the information from the network should be dealt with and to be managed. However, no matter from the physical storage space or network interface card, these devices are of physical hardware. The operation system should use the low-level interfaces to communicate with the physical hardware. Of course, the device drivers will be embedded within these interfaces. So the kernel or the file system or network protocol stacks can interact with the physical hardware through the low-level interfaces. Then, the operation system also provides high-level abstractions to manage the requirements or command from the upper level. A client user may only use the applications, and this software or application can send the command directly to the kernel through the high-level abstraction. Then the kernel can deal with the computing job or to manage the commands. Or the software or application will need the existence of the library provided by the operation system. With the existence of the library, the kernel can execute the command from the software. In addition to the application or library, there are also command processor. We also call shell. Hence, in the Linux operation system, especially the Linux kernel, the computing job should be executed. The file system should manage the data file in the storage space, or the packet is changing in an internet or a network. All the computing job or work should be managed by the Linux kernel or the operation system. Hence, similar to the traditional operation system, the cloud operation system should also provide the interface to deal with the hardware resource, especially in the node, computing resource node. There will be the interface to deal with the hardware and provide the hardware resource information to the upper node, or we call cluster node, even the cloud controller or cluster controller. In addition, each computing resource node will deal with the file system. All the data in the cloud operation system will be divided into blocks. So, which block is storage in a specific storage space should be recoded and create a mapping table. The cluster controller will manage all the information, but the computing resource node will also deal with the physical data storage space. So no matter in the computing node or the cluster controller, even in the cloud controller will equip the file systems. They have different functions. And since all the cloud platform is established based on the network, all the computing node, cluster controller, or the cloud controller should equip the network protocol stacks. However, according to the location in the operation system of the cloud platform, the high-level abstraction will be has different functions and ability. For example, the cloud computing node only provide the computing resource information, or provide the information of the computing job execution result to the higher node. The cluster controller will provide the suitable or the information filtered to the cloud controller. And the cloud controller will present the usable or available computing resource, the user interface to interact with the remote client user. So, in a cloud environment, each node will equip an independent operation system They has some functions similar to the traditional operating system. However, the whole cloud operating system integration will be almost similar the same as the traditional operating system to the remote client user. So you need to know which operating system we describe. In the past, the computer operation system related to the cloud computing is already proposed and implemented. The first is the distributed operation system. The second is a network operating system, similar to the DRBL, the diskless remote booting system. The third is the cluster operating system. To manage a cluster or some computing resource and merge as one computing resource pool. The cloud operating system is similar to the traditional computer operation system. However, in the cloud computing, we focus on the shared computing resource pool of configurable computing resource. For example, network, servers, storage, software or applications, and its service provided from the cloud environment. All these computing resources should be merged as the computing shared pool for the remote client user for the repeatedly and rapidly used based on the network. What is cloud computing system? The operation system has the responsibility to manage the low-level cloud resource, especially in the computing node. All the cloud computing resources should be merged as the computing resource pool. And second, the cloud operation system will hide the cloud infrastructure details from the application programmers. So the program developers needn't to know the infrastructure of the cloud. Indeed, the programmers or developers only need to use the virtual machines without understanding the cloud infrastructure details information. And especially, the cloud operation system should coordinate the sharing of the resource. Since we cannot predict the computing resource required from the client user, we need to merge the computing resource from different computing nodes, the physical computers. Hence, one virtual machine may be integrated from different physical computers. To the client user, the user needn't to know where the computing resource comes from. The client user only need to give the on-demand computing resource requirements to the cloud operating system. If the cloud computing resource can satisfy the requirements, the virtual machine can be implemented and established for the client user via internet. So, the computing operating system try to virtualize all the computing resource and merge all the computing resource as the service to the client user. And the user needed to know the infrastructure information. So, similar to the traditional computer, the cloud operating system still need to manage the computing resource in each individual computing node, the physical computer. Each physical computer or computing node should provide the computing service to do the really computing job, to deal with the real existed file. So the physical computer with the cloud operating system should manage the storage, should have the file system to provide the storage space. In addition, each physical computing node or computers should be connected by the network for the cloud environment establishment. So each computer with the cloud operating system, similar to the traditional computers, should provide the communication service between different physical nodes in the cloud environment. The differences between the traditional operating system and the cloud operating system, the most obvious difference is large scale. The cloud operating system should manage the cloud infrastructure. The huge computing resource should be managed and suppose a very large number of users' requirements. These requirements or computing job will be executed maybe in the provided virtual machine. So the cloud operating system should provide the computing power in the forms of a virtual machine, no matter the computing resource come from. In other words, the cloud operating system should deal with the cloud computing resource from huge number of the physical computing node to manage the file, no matter storage in which individual physical computing node. Similar to the MapReduce, all the data will be divided into different individual physical machines for execution. Then collect all the computing results to the client user. This should be done by the cloud operation system, even the eventual consistency. So, to manage the computing resource, the file from the client user in the huge number of the client computing node, the cloud operating system is so different from the traditional operating system. So, one operating system to be the cloud operating system, the first is to permit autonomous resource management. Since the data center requires so much huge computing resource, the cloud operating system should well manage the computing resource. And the cloud operating system should continue to operate despite the loss of a node. Even some physical machine is out of order or out of service, the whole system should be still good for the client user. The cloud operating system should be an operating system and architecture agnostic. It supports multiple types of applications, no matter in the IaaS, PaaS, or SaaS. Different requirements from the client users. The cloud operating system should provide a decentralized and scalable management. In other words, one physical node crash will no affection to the whole cloud system, no matter in the cloud computing resource or the file system. One node crash, the cloud operating system still work and provide the service continuously to the remote user. The cloud operating system should support accounting on resource usage. Business is business. How to evaluate the resource usage means how to have the income, how to evaluate the cost. The cloud operating system should give the evaluation and support the accounting. Then, the cloud provider can survive with the income.